Okay, this is the review for Unit 1. It's all about parent functions. So the first thing we're going to talk about in Learning Target 1 is the domain of functions. So we're going to focus primarily on domain. Now when we talk about domain, you have to remember that domain represents the x's only. That's going to come into play when you look at a graph. So in problem 1, it says given the graph, you get this wavy graph with two white dots at each end. The main thing about your domain is you want to try to find the extreme x values. So you want to see how far to the left and how far to the right it goes. On the far left end of the graph, there is a white dot. On the far right side of the graph, there's a second white dot. Now, since I only care about the x values, I'm going to draw some lines that go from each white dot back to the x value. Then I'm just going to count that up. So if I start at the origin, I would go left 1, 2, 3, 4, 5, 6. So the left dot is at -6, and the right dot appears to be at +2. So that means that the graph exists from -6 to -2. Now, because they have white dots mean you don't include the actual -6. So in your interval notation, you would just use round parentheses. Number 2 says, given the function f of x is equal to the square root of 12x minus 3, and that's all in the square root, state the domain. And when you're talking about a domain of a square root, you always take the stuff that's inside and you set it greater than or equal to 0. Then you pretend like it's a regular equal sign and you just solve it. So I'm going to add 3 to both sides. So I'll have 12x greater than or equal to 3. Divide by 12 on both sides. And I end up with x is bigger than or equal to, now 3 over 12, if you type that into the calculator, it tells you that it's 1/4. Now, to be honest with you, I don't care if it's a fraction, a decimal, I don't care what type of number it is. You've seen that in class when I draw a number line, I just mark the number that I need. So I just need to mark off 1/4 on this horizontal number line. Now, this states that x has to be greater than or equal to 1/4. So I'm going to put a circle at the 1/4, and I'm going to color it in. You color it in every time it's equal to. Now, the values that are bigger than 1/4, if you're looking at a number line that's horizontal, bigger numbers are to the right. So then we would draw an arrow extending out from the dot pointing to the right. So once I have this picture, I can now come up with my interval notation. The graph would start at 1/4, and then it would head off until positive infinity because it never stops going. Infinities always get parentheses, and that black dot at the 1/4, because it's equal to, will get a bracket. Brackets mean that you're also including the 1/4. Now, if you go down to problem 3 is a review from the first chapter. It says, given the function 3x squared minus 2x minus 8 all over 7x plus 4, it says state the domain. Now, when you're talking about a fraction, you don't need the top. So I'm just going to cross out the top. I could care less about the top. So I'm just going to take the bottom, 7x plus 4. And every time you have a fraction, you just set it equal to 0. So I'm going to take the bottom, 7x plus 4 equal to 0, and then subtract 4 from both sides so I can solve for x. So I'll have 7x equals minus 4, and I'll divide by 7 on both sides. If you type that in the calculator, it just stays as -4 over 7. Now, here's the thing about fractions. This is actually the number that we don't want. So I put a slash through the equal sign. So every other number would work except the -4/7. So if I was to demonstrate that on a number line, I would actually have a white circle at -4/7. I would extend an arrow pointing to the left to indicate that every number to the left of it works, and then every number to the right of it works. So I would extend an arrow from the white circle out to the right. Now, the reason why the visual is so important is because then you can generate your interval notation based off of this picture. If the graph is pointing to the left, your domain is going to be coming from -infinity. Now, that graph cannot touch the -4/7. So anytime you have to skip a number, you just write the number -4/7 with parentheses, you put a U, and then you put the same number a second time, and then comma infinity. So if you can imagine following along the line, once you get to the white dot, you're going to jump over the white dot and then go to the other side and continue going. So that's where that union comes in. This is how you say every number except that one. you just write that number twice, the U in the middle. And because it's not allowed to be the 4/7, we use parentheses instead of brackets. So these types of answers will never ever use brackets. Okay, learning target 2 is the key features of the graphs. So you have quite a few definitions that you have to remember. For instance, the root has multiple names. You can call them roots, you can call them solutions, you can call them x-intercepts, you can call them zeros. No matter what you call them, the roots are always the points along the x-axis, wherever the curve or the graph touches the x-axis. Looking at this graph, it appears that it touches at 4 different locations. And then it just depends on how, the software that you're using wants you to enter the answer. Sometimes you can enter it as a point, so you can write it as -3, 0, and then -1, 0, and then +1, 0, and then 3, 0. That's one way you can write the roots or the zeros. Another way is just you say x equals -3, x equals -1, x equals 1, and then x equals 3. Now I'm going to save the increasing and decreasing stuff for later. So let me go on to the end behavior. I like to do these in order of difficulty. So in my opinion, the end behavior is the next easiest one to do. When it talks about end behavior, it's asking you what are the ends doing. So if you look at the left end has an arrow pointing up. When you read the notation, it says as x approaches -infinity. Now, anytime it says x negative, that means the left side. So since the left side is pointing up, our f of x, which is the fancy way of saying the y's, are headed towards positive infinity. Up is always going to be positive infinity. Now, if you look at the right extreme or the right end also has an arrow pointing up. If both arrows are pointing in the same direction, you can expect the answer to the end behavior to have the same exact answer. So as x approaches positive infinity, that means to the right. F of x, which is a fancy way of saying y, is going up. Now we don't write the word up, we just write positive infinity. So that's our end behavior. The next one is the domain and the range. So let's start with the domain. The domain is how far to the left and how far to the right the graph goes. The left side has an arrow, so that tells me my domain goes to -infinity on the left. The right side also has an arrow, so that tells me that it never stops, so it's going to go to the right forever. So my domain would be, for this picture, from -infinity to infinity. Now the range is similar, except now we're going to use the y values. So we have to find the lowest and the highest that the graph can go. So we're looking for the extremes. Now this graph has 2 dots, but they look pretty level. They look like they're both at -15. And that on the y-axis has a black dot, so we're going to put a bracket. Then if you look at the top, a lot of kids get confused and they want to use this hump at the top of the graph, but you have to remember that these have an arrow. Arrows go further than that hump. That arrow indicates that the graph is continuing to go up forever. So this graph is going to go up nonstop. So the second number for the range is going to be infinity. The next thing we're going to talk about is the maximum and the minimum. The maximum is going to be the top of the speed bump. So that's going to be at this spot right here that I marked, right at the top of the graph. So the maximum is at 0,9. The minimum is going to be as if you were to flip a speed bump over. So it's going to be like a valley. So this one actually has 2 valleys. There's one located at parentheses -2, -15. And the second one is located at +2, -15. Now we don't have to put u in between those because these aren't intervals. These are actual points. They're actual locations. An interval is like a list that has a lot of numbers in it. So these aren't lists. These are actual locations. Okay. Now I want to go back to increasing and decreasing because you base your increasing and decreasing answers off of the maximums and minimums. So since we had a maximum at 0, 9, I'm going to go down to the x-axis and I'm going to put a big fat 0 right there. Since I had a minimum at -2, I'm going to go mark -2 on the x-axis. I'm going to put a big fat -2 right there. We also had a minimum at +2. So I'm going to go mark off the x-axis at +2 and put a big fat 2 right there. Then I'm going to mark off the extreme left end of the axis as -infinity, and then the extreme right end of the axis as +infinity. What we're going to do now is we're going to just break down the graph into whether it's increasing or decreasing. So when we read the graph, we go from left to right. So the left part of the graph starts off, if you imagine riding a roller coaster, it's headed down. So the first answer is from -infinity to -2. That's going to be the section of graph that's decreasing. So for decreasing, we're going to start off with -infinity to -2. Now, once we pass that minimum, then we start heading up. So this graph now is heading up until it reaches the maximum. So the next group of numbers that we're going to put into our answers is going to start at -2 and it's going to go to 0. That's the next chunk of graph when the graph is headed up. So since that's headed up, that's going to be my increasing section. So that's going to be from -2 to 0. Now, once we get past the maximum, if this were a roller coaster, now it starts heading down. Let me change my end over here to an arrow. So now I'm headed down, 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 down until we get to the minimum. That's why the maximums and minimums are so important. So the next section goes from 0 to 2. So all we're doing is breaking the graph into sections so that we can write these sections as answers. And we're using the x values only. That's why it's so important to write all over your x-axis. So my graph starts dropping at 0 and it stops going down at 2. So my decreasing section is going to be from 0 to 2. So this is the second decreasing section. So I'm going to put a union and I'm going to say from 0 to 2. And I'm not sure what happened to my increasing section. I don't know if I wrote it down or not. So I'm going to add it. I'm going to put -2, 0 for the increasing answer. Now I have one more section of graph to cover. I ended at 2, so I'm going to start at 2 and I'm going to go to the next number. The next number is infinity. So again, this graph, it looks like it is, once we get past the minimum, the graph is headed up forever. So when we write our increasing section, I'm going to put a U, and it's going to start from 2 and then go off to infinity. So the increasing and decreasing stuff, I usually save that for the end because I write all over the graph. So now let's do the last question. I don't think this one is difficult. This one says, find the average rate of change between the maximum and the minimum. I think the only thing that can get complicated is there's 2 minimums. So pick one. It doesn't matter. If the test has 2 maximums or 2 minimums, we'll have both answers, so you don't have to really worry about that. So what I'm going to do is I have to use the maximum because there's only one of them, and I'll just pick I'll pick the minimum that has the least amount of negatives. So I'll be using 2, -15 for the second one. Now, in order to do this, I have to label my points. So this is going to be x1 and y1 for 0, 9, and then x2 and y2 for 2 and -15. The average rate of change formula is y2 minus y1 over x2 minus x1. And now I just have to substitute, which means I have a bunch of parentheses with a minus in between each set of parentheses. So I'm going to substitute the y2, that's going to be -15. I'm going to substitute the y1 next on top, so that's going to be a 9. Then I'm going to substitute x2, that's a 2. And then I'm going to substitute x1, so that's a 0. Now you can type this entire thing into your calculator. If you were to type all of this into your calculator, I believe the answer, let me see, 24 divided by 2, I think the answer would end up being -12. So that's our average rate of change for that picture. So if you didn't understand it, for that first example, number 5 and number 6 are still, I mean, they're all kind of the same question, just different graphs. So in number 5, it looks like we have a cubic graph. The left arm is pointing up and the right arm is pointing down. Let's do the roots first. So the roots happen anytime the graph touches the x-axis. So it looks like this one has 2 roots. And actually it has 3. If you notice the graph where it touches and bounces off, that means it's a double root in that section, but that's a little advanced for this test. One of the roots is going to be at negative 2 comma 0, and the second one is going to be at 3 comma 0. We're going to save increasing and decreasing for last since we have to draw all over the place. So now let's do the end behavior. End behavior looks at just the ends of your graph. So I want to look at the left end and the right end. Now if you just look at the graph, one end goes up and one end goes down. So that means that your answers cannot be the same on this. But you do need to make sure you understand how to read the notation. This says, as x approaches negative, that means the left side. My left side is pointing up. So that means I have to put a positive infinity for that answer. The second one says, as x approaches infinity, f of x approaches the right side. Anytime it says, as x approaches positive infinity, that means the right side. The right side is pointing down. Down is negative infinity. Okay, now for the domain and the range. This one is my favorite. Domain means how far to the left and how far to the right using the x-axis. This graph has an arrow on both ends, so it's going to go left forever and it's going to go right forever. Now when we do the range is going to use the y values, but we're going to go from the bottom to the top. The bottom has an arrow and the top has an arrow. So again, my range is going to be negative infinity to infinity. Infinities never, ever, ever use brackets. So they'll be in parentheses. Now for the maximum, this graph does have a maximum, and the nice thing about it is it's at the top of the hill, so it's already marked for us. Our maximum is at 1.5, comma 4.5. It does have a minimum. The minimum is the valley. It's the lowest point where the graph goes down and then up, and it looks like that one is at negative 2 comma 0. And if I want to do the average rate of change between the maximum and the minimum, I'll do that after. Let's do the increasing and decreasing since it uses the maximums and minimums. So I'm going to mark off my maximums and minimums on the x-axis. So I'm going to put a giant 1.5 and I'm going to put a giant negative 2. Then at the very, very end, I'm going to stick a negative infinity, and the far, far right side, I'm going to put a positive infinity. So when you create your answers, you just go from the first number to the next number. So the first set is going to go from negative infinity to negative 2. Then we're going to go from negative 2 to 1.5. Then we're going to go from 1.5 to infinity. That's why it's important to mark this graph up. Now we just got to figure out what the graph is doing, if it's going up or down. This graph, when you go from left to right, if you were riding a roller coaster, it starts off by dropping. So that's going to be a decreasing section. So my decreasing interval is going to go from negative infinity to negative 2. The next section of graph looks like it's, once you pass the minimum, it looks like it's heading up towards the maximum. So that's going to be an increasing section. So it's going to be increasing from negative 2 until 1.5. So we'll put parentheses negative 2 comma 1.5. And then once we get past the maximum, the graph drops again. So that next section is headed down. So the next section we're going to write, since that's the decreasing section, we're going to put a U, and then we're going to put 1.5 comma infinity. And that's our increasing and decreasing intervals for this graph. Now we can do the average rate of change. So if we're going to do the average rate of change, we need to label the points. So I'll put x1, y1 as the 1.5 and the 4.5, and then I'll put x1, or actually x2, y2 for the negative 2 comma 0. So using the formula y2 minus y1 over x2 minus x1, we would follow the format and put 4 sets of parentheses. And in between each set of parentheses, we'll put a minus sign. So starting with 0, y2 goes first, so I'm going to put 0. And then y1 goes next, so that's 4.5. And then let's see, we've got x2 is next, so that's negative 2. And then x1 is after that, so that's 1.5. If you type all of this into the calculator, it gives you negative 4.5 over negative, what's that, 3.5? And those two negatives are going to cancel and become positives. And then Your calculator might turn it into a fraction, might turn it into a decimal. No matter what it is, you guys, just put whatever the calculator says. I'm going to leave mine though as one, 4. Actually, you know what? I'll pull up the calculator and just do it. I was going to be lazy. So let me type in into the regular calculator, ABC 4.5, and then down at the bottom, 3.5, enter. So it gives me this long decimal, and if I hit the FD button, it turns it into a fraction. So you could either put the decimal or you can just put 9/7. Either way, we'll probably have both answers on the test, so you don't have to worry about that. Okay, next one. Next one asks for the roots. The roots are on the x-axis. This one has 2 roots. So this one is at x equals -2 and x equals +2. So I decided to change it up on you. And instead of writing it as a point, I'm just writing it as x equals. Let's do the end behavior. So the end behavior, it talks about the ends of the arms and which way they're pointing. Looks like both arms are pointing down, so that's going to be a -infinity for both boxes. So as x approaches -infinity, f of x approaches -infinity. As x approaches +infinity, f of x also approaches -infinity because it's a down-down graph. Okay, domain. Now this graph doesn't have any arrows, but because it goes all the way to the edge, if there was a grid here, that means that they have arrows. Now I love when a graph has an arrow on the left and an arrow on the right because that means that the domain is going to be -infinity to infinity. This covers all x values because it goes left forever and right forever. When we do the range, we're going to go from the lowest to the highest. Now I can't get to the lowest point because the graph has an arrow pointing down, so that means the graph is headed towards -infinity. I can get to the highest point though. The highest point, it looks like the highest y value is going to be at 0, and those are black dots, so I'm going to use a bracket. Maximums. This one has 2 maximums, so there's one maximum at -2, That's the top of the speed bump. And then there's a second one at the top of +20. So that one has 2 maximums. This also has a minimum, and you're going to have to estimate. It doesn't look like it's quite at -15. So I'll say that that's at, I don't know, this point right here. Let's estimate it to be at 0, -16 or 17. I'll just call it 16, whatever. So that's our minimum. After I mark my maximums and minimums, I like to do the increasing and decreasing because it's all based off those numbers. So I'm going to mark off -2, I'm going to mark off 0, and I'm going to mark off 2 on the x-axis. I'm also going to put a -infinity on the far left and a +infinity on the far right. And then I'm just going to go from number to number. So from -infinity to -2, that portion of the graph, if you read it from left to right, looks like it's heading up. So my increasing section is going to be from -infinity to -2. Wherever you end from, that's where you start from your next section. So I'm going to start at -2 and go to the next number, so that's 0. That graph, if you were to trace it from left to right, that graph is dropping down towards the minimum. So from -2 to 0, that's going to be my decreasing section. Then I use the next pair of numbers. So since I ended at 0, I'm going to start at 0 and go to 2. So 0 to 2, if you look at the graph and trace the graph from left to right, after you pass the minimum, you start heading back up towards the maximum. So that's an increasing section. So I'll put a union since I can't fit it in there. And I'll say from 0 to 2 for my increasing section. I have one more section to cover. So if I ended at 2, I need to start at 2 and go to infinity. Now that part of the graph right there, if you trace it from left to right, once you pass the maximum, it starts dropping down forever. So that decreasing section is going to be union 2 to infinity. Then what we're going to do is, again, average rate of change. So let me clear off all this mess. Average rate of change from the maximum to the minimum. You can pick any maximum you want. I like picking the ones that don't have negatives. So I'm going to pick this one here, and I have to use that minimum value. So I'll use x1 and y1 for the 2, 0 point, and I'll use x2 and y2 for the 0, -16 point. So I'm going to put my little parentheses into this fraction and in between each set of each entire set of parentheses, we're going to put some minuses. So y2 goes first, so you put negative 16. Y1 goes next, so then we put 0. X2 goes at the bottom of the fraction in the first parenthesis, so I put a 0. And then X1 goes second, so I put the 2. You can type this whole thing into your calculator. If you type that into your calculator, it's going to tell you that the answer is 8. If you were to use the other two, the other maximum with that single minimum, the only thing that changes is the sign, because they're at the same level anyway, so they'll have the same number, just different signs. Okay, now we're going to go into learning target 3. Learning target 3 is describe the transformations. So number 7, it says given the graph the given functions and identify a, h, and k. So I'm just going to list a, h, and k really quick here. So a is always found in front. So that negative means that a is equal to -1. The h is the one that's inside with your x, and you can't trust that one because it's with your x. So your h is going to equal -4. And then your k is always at the end, and you can trust that one because that one's not with your x. And you know what I'll do? I think on the test, all you have to do is list a, h, and k, but just for a review, I'll talk about what each of these do to the parent function. So this graph, when it has the a, that a of -1 is a reflection. The h of -4 means that the graph is moving left 4. And then the k of 5 means up 5. It's not really asking you to do that. It's just asking you to find a, h, and k, but I'll do it because it's good review. Okay, next. Number 8 says g of x is equal to parentheses x plus 2, close the parentheses, to the third power, and then there's a -1 at the end. So a in this problem is going to be the 1 in front. H in this problem is going to be the -2, and then k in this problem is going to be the -1 at the end. Now, since a is 1, I don't have to talk about it because on the parent function, a is 1. So if a were to change, that's when I have to talk about it. H is -2, so that means left 2. And then k, oops, I already have the k written. K of -1 just means down 1. Okay, next is cube root. So a, h, and k never change though. A is in the front, h is inside with your x, and k is at the end. So that means a is equal to -2, h is equal to -1, and then k is equal to -3. So if we want to talk about what these do, so a does two things. A is going to be a reflection because of the negative, but it's also going to be a stretch because of the 2. Anytime you have a number higher than 1, it causes the graph to get taller, so it's going to be a stretch. H of -1 means left 1, and then k of -3 means down 3. Okay, last one. This is an absolute value. That one will look like a V. A is in the front, so A is -2. H is inside, and you don't trust H because H is with your X, so that's going to be -1. And then K is equal to -3. You can trust that one because it's not with your X. So again, negative is a reflection, and then 2 is a stretch. H of -1 means that we're going to move left 1, and then K of -3 means we're going to move down 3. Next page is a little bit more of the same. The only thing is you got to compare it to the vertex of the original, of the next section right here. So the vertex of the original, that's the parent function. So that one's at 0, 0. So if I want to describe how it moves, I have to find the vertex of the second one. The vertex of the second one is going to be at +1, 4. Now the reason why I know that is because every vertex is just your h and your k. H is on the inside, K is at the end. Now, the reason why it's important to do that is so that you can compare the x's to the x's and the y's to the y's to see how it moved. So if you're at 0 on the x-axis and you go to 1, that means you went right 1. And you can draw it out if you need to. I don't really care. Now, if you look at the y's, you compare the y's with the y's. So if you started at 0 and you went to 4, that's going to be up 4. I don't know why that didn't write the number for me. It's going to be right 1 and up 4. Now you have to also pay attention to the front. The front of the first one doesn't have anything, so that means it's a 1. So this front has the negative. A negative is a reflection. And then it also has the 2, so that's going to be a stretch. Okay, next. Next one, vertex on the first one is at 0, 0. The vertex of the second one is going to be at -1, -9. So when you do these comparisons, you do the x with the x. So if I start at 0 and I go to -1 on the x-axis, that's going to move left. So I go left 1. And you can draw this out if you need to. And if I look at the y's and compare each y, I have a 0 where I start from and a -9 where I end at. So on the y-axis, if I start at 0 and I go to -9, that's going to be down 9. I don't like the way I wrote the 9. It looks like an A. So let me write that again. Down 9. That's better. And then we compare the fronts to see if it's got any stuff in the front. This one has the negative, so that's going to be that reflection again. So those are your 3 transformations. Okay, the next one gets a little fancier because now you're not at the origin anymore for your parent function. So the parent function of this first one is going to be at -1, 5. And the second one is going to have the vertex at +4, -1. Now, since we're not dealing with zeros at all, it might be a good idea to just actually draw the x-axis. So let's look at the x's first. I'm starting at -1, and I'm going towards +4. So this is 0, this is 1, this is 2, this is 3, and this is 4. So if I count how far I had to go 1, 2, 3, 4, 5 to the right. So that's going to be my first thing I'm going to write down. 5, I'll put right 5. Then I do the same thing for the y-axis. I'm going to start at 5, and I'm going to count down to get to -1. So here's -4, 3, 2, 1, 0, and then here's -1. So if I count which way I went down 1, 2, 3, 4, 5, 6. So this is going to be down 6. Now you look at the fronts. The fronts are the same on both of those, so we don't have to talk about those. Okay, we're going to do that again for the next one. Let's find the vertex first. The vertex is at 3, -2. And the second vertex is at 7, 10. Okay, so x-axis first. I'm starting at 3, and I'm going to 7. So here's 4, 5, 6, 7. So I'm actually moving to the right, 2, 3, 4. So my first answer is right 4. Then I do the y-axis. I'm starting from -2, and I want to go up to 10. So this would be -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I ran out of room. Let me just extend that. Then I just need to count it up. So I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I went up 12. Then we compare the fronts. The front went from a 1 to a 1/2. So that means A is equal to 1/2. So anytime A is a fraction, that's going to be a compression. You can just write the word compress if you don't want to spell out the whole word compression. And they get fancy sometimes and they'll say compression by a factor of 1/2. I don't care. As long as you say the word compress or compression, I'll be happy. Okay, number 15. Number 15 does the same thing. So number 15, we're going to find the vertex for the first one. It's going to be at 2, 7. And then the vertex for the second one. Notice how the second one doesn't have any numbers in there with x. So that means that's a 0. So the second one's going to be at 0, 1. So if I'm doing the x-axis, I start at 2 and I go to 0. So 1, 2 to the left. So that's going to be left 2. Then if I do the y-axis, I'm starting at 7 and I'm going to 1. 6, 5, 4, 3, 2, 1. There's 1. Count that up and you're going to hit 1, 2, 3, 4, 5, 6 down. So this is down 6. Now you look at the fronts. The front was blank on the first one, and now it has a negative and a 3. The negative part is going to be the reflection, and the 3 is going to be the vertical stretch. Okay, now it says we have to start writing equations. So write the equation of the square root function. It's going to be important to know what's what, because, I mean, you can't, they're spelling it out for you, so you have to just memorize what a square root symbol looks like. So when it says square root, that means a square root symbol. It says reflected over the x-axis. Now remember that a reflection means that a is equal to -1, so I stick a negative in front. You can write the 1 if you want to, but you don't have to. Then it says shifts left 3. Now be careful with your left 3. When you have an x inside your radical and they want you to move left 3, that one is lying to you. Left 3 would be -3, but because they're lying, we're going to put it as a +3. And then the last part says up 2, so we just stick a +2 at the end, and that's our answer. So we have negative square root of x plus 3, and then on the outside +2. Okay, next one says write the equation of a cube root. So anytime it says root, it's one of the radical symbols, and if it says cube root, you put a 3 on the little step. It says stretch by a factor of 2. Remember I said sometimes they say it fancy? So that right there is the a. So I put a 2 in front. It says shifts to the right 1. So let me stick the x on the inside. Now technically, right 1 would be +1, so I'm going to put it as -1 once I put it inside with my x. And then I have the up 6. Up 6 goes at the end. So my equation should be 2 cube root of x plus, or x minus 1, and then +6 on the outside. Okay, last one. Write the quadratic. So a quadratic is going to have a parentheses with a squared on the outside. So I'll stick the x on the inside right away. It says compressed. Compress, stretch, and reflect, those are all front numbers. So I have to stick a 1/3 out in the front because 1/3 is the A. Then it says to reflect it over the x-axis. A reflection is also the A, and that means that A is equal to -1. Now there's already a number there, so I'm not going to put a -1. I'm just going to make it negative. So I put a big old space right here. So you don't need the big space, but your answer is going to be -1/3 x squared. And technically, you don't even need the parentheses around the x since x is all alone. Okay, number 19. Number 19 says, write the equation of the cubic function. Now, a cubic function means to the 3rd power, so I'm going to put parentheses with an x in it, and I'm going to put an exponent of 3 on the outside. It says reflected, that means a negative, and then it says shifted left. Left means it has to go inside with x. Left 5 would be -5, but I don't trust them, so I'm going to put a +5. And that's the answer. I end up with negative parentheses, x plus 5, close parentheses, to the 3rd power. Number 20 says, write the equation of the absolute value function. Okay, absolute value means the 2 bars. So we got the 2 vertical bars with the x on the inside. It says reflected. Reflection means a negative in front. Down 5. Now be careful because they don't always give you stuff in order. Down 5 means -5 goes at the end. And then right 3 would be +3, so I'm going to stick it as a -3 in here. So I'll have negative absolute value, x minus 3, close the absolute value, and then -5 for my final answer. Okay, number 21 says, describe what a, h, and k tell you when translating the function. So remember that a does 3 things. It depends on what the number is. If it's negative, a negative causes the graph to flip, but we call that a reflection. If a is bigger than 1, that's a stretch. And if a is a fraction, I'll just write fraction. If a is a fraction, that's a compression or a compress. H is responsible for your horizontal movement, so that tells you that it's left or right. But it's always in the opposite direction that it shows you. K is responsible for your vertical movement, so that's your up and down movement. Okay, learning target 4 is odd and even functions. It says mark each function as even, odd, or neither. So I want to review with you how to tell if it's even, odd, or neither. So let's say even first. If you're looking at the equations, all exponents are even. I'm going to emphasize the word all. So that means that all exponents either have a 0, a 2, a 4, a 6, dot, 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 forever. So when you guys do these problems, you have to always take a look at the last number, because if the last number doesn't have a letter, we have to add a letter and make it to the 0 power in order for this little life hack to work. If it's odd, odd means all, emphasis on all, exponents are odd. Odds are 1, 3, 5, 7, 9, 11, dot, dot, dot. And then if you have neither, neither happens when exponents are mixed. And by mixed, I mean both evens and odds. So we're going to go through and we're going to just put an E for even, O for odd, and N for neither. So the first one has an even, and we have to put an X on the number, so that's a 0, which is also an even. So since everything is even, I put an E in the box. Okay, second one to the right says y equals 2x squared minus 4x. First one has an exponent of 2, so that's even. Second one has an exponent of 1, but that's odd. So if the exponents are mixed, that's neither. Okay, next one. It says negative 2x to the fifth plus 2x to the third minus x. So 5 is odd, 3 is odd, and this has an invisible 1, and that's also odd. So since every single one is odd, the answer is odd. The next one says 1/3 x to the sixth plus 5x to the fourth plus x squared. That's even. 6 is even. 4 is even. And 2 is even. Since all of them are even, that makes an even function. Okay, next one. The next one doesn't have an x on the last one, so I'm going to put x to the 0 because they all have to have x's for this to work. So the first one is even. 4 is even. 0 is also even. So since they're all even, that gets a capital E for even. Okay, the last one has an exponent of 3. This one has just a regular plus 1. It says 5x to the third plus 1. So I'm going to put my own x, but I'm going to add a 0 to it. So that one is odd, and 0 is even. So odd and even is mixed, so that's going to be a neither. Okay, last couple of questions. It says determine if the function is odd, even, or neither. But now you have a picture. If you have a picture, you have to remember that even happens anytime you can cut the graph in half at the y-axis. So this graph right here, this is an example of even. Okay, the next graph, it's a little different. You try to cut it in half, not going to work. I can't fold this directly in half at the y-axis. So we know for a fact that this is not going to be even. The next thing we have to check for is odd. So let me show you how to check for an odd graph. I'm not even going to use the entire graph. All I'm going to do is go to the origin and verify that it touches the origin. So when we're doing an odd function, we need to make sure that it crosses the origin. So check, that works out. The second thing that has to happen in order for this to be an odd function is a lot of times they're going to be diagonal from each other. If you look on each side of that point right at the center, if you go to the left side, the graph is going up and left. If you go to the right side, it's going down and right. 9 times out of 10, if they're going diagonal, which this one is, this is going to be an odd function. Now, guys, when you do this on the test, I believe the test is going to have one of each. So try not to repeat your answers. And I believe that is the end of the review. So hopefully you find this review helpful, and that way you can dominate the chapter 1 test.